I am going to present to you cutting optimization. So this tool enables you to schedule cuttings and optimize offcuts for design based on mechanically welded sections. With cutting optimization, you can optimize your cutting and material procurements. You can also retrieve SolidWorks weldment tables, and you'll also be able to optimize offcuts based on raw materials. So I'm going to show you how it works and how you can manage to have a report at the end that shows us cutting and direction of rotation, which is the advantage of using 3D data. So first of all, this is the tool. You can find it here. And here what we're going to do is that we're going to start a new table to have a new report. So we're going to click here. So this is what it looks like. So we're just going to make it bigger. So here you have the project information. Here you'll be able to deal with your choice of beam length. And here, this is where we're going to enter all project elements. So what we want to do is click here to import an assembly. So as you can see, it's right there. So we're going to scan it by clicking here. So now, as you can see, all my welded profiles are here, so I can apply it. And here, as you can see, they are all tidied by sections. You can also see the length, the quantity, the height, or the angles, also the rotation. What we want to do now is to see our choice of beam length here. So as you can see, there's two choices, compulsory and defined by profiles. The goal here is to see with which lengths you'll have the less lost. So here on compulsory, we have a 6,000, but you can completely modify it. And here, if we see defined by profiles, we will be able to select for each length two different sizes. So we'll be able to see with which one will have the loss less. So here, by example, what you can do if you want to have a little more and better visualization, you can click here to set random colors on each profiles. And here we're going to go on those sections and we are going to see what we have if we choose the compulsory 6,000 length. Now that we chose it, we can launch the report. So as you can see, it's giving me a report, so I can see the total offcut I have with this choice of lengths. So here, if I'm choosing this length, which was 6,000, I have a total offcut of 1,370. So let's see if we can define it. So we are still on the same section. So now we're going to deduce between 4,000 and 7,000. And we are just going to change the fineness of iteration to 50 by example. And we can launch the analysis. So as you can see here, the length I will have the last of offcuts will be 4,200. So we're going to launch a new approach to see the total offcuts. So now, as you can see, with the same section of profiles, I have a completely different total offcuts, which is 86. If you remember, the first one we did was a lot more total offcuts than the new one we have now. So the advantage with this report is that we can see the rotation, so you can give it to the manufacturer. If you need so, it will be a lot more practical. Also, if you have only two options for your length, you can choose to go here with this part, so length of 4 bars, where you can select two imposing lengths, so first one here, second here, or you can also separate flows in batches if needed. To conclude, in this report, you'll have the length cutting list for each section of profiles, as you can see. So this is it for cutting optimization. Do not hesitate to use it if needed.